Mean value theorem for integrals. This is one of those like heavy hitters on the AP exam. This will show up multiple times, and it's one of those questions where like I don't want to start negatively, but it's one of those questions where a lot of people get them wrong on the AP exam, and so I wanna spend time on this. I want to go through it carefully. I want us to understand where the stuff is coming from. So take this lesson slowly. If something doesn't make sense, pause it, look at it again, and we'll make sense of it. Further, if you have questions, we can absolutely talk about them in class. So from the get-go, don't give up. So here we go. I'm going to start by writing out the mean value theorem. I'll just type it out for you. So here it is, the mean value theorem for integrals. It really only has one requirement. In order for this theorem to apply, the one thing that has to happen is that the function has to be continuous on the interval from a to b. So assuming that the function is continuous on the interval, then there is at least one value c between a and b such that this statement here is true. And I know with these theorems, it's just like, oh my god, letters everywhere. What is this even saying? Let's dissect this thing, because it's really not that bad. The thing on the right side should be completely recognizable to you. This thing here is the thing that lesson 4.12a and b were both about. This is the average value of f of x on the interval from a to b, right? And the thing on the left is just saying f of c. This is just, and what is c? All the problem tells us is that there must be at least one value of c where this happens, right? So the thing on the left is just almost like, any value of f. This theorem is effectively saying if the function is continuous, then there has to be one place where the value of the function is equal to what the average value of the function is. So I'm going to say that again. The mean value theorem for integrals says that if you've got a continuous function, it'll happen at least once that the specific value of the function is equal to the average value of the function. The best hope of this making sense is to go into an example, so I'm going to jump to that right now. So the question being asked is for us to find the value of c guaranteed by the mean value theorem for integrals for the given function on the given interval. I really feel like this is more or less a three-step process, and so over on the side I'm going to outline those 3 steps and then we'll actually go through it. Step 1 is to find the average value of the function. Step 2 is then to set that average value equal to the function itself. And step 3 is going to be to solve for the value of c. Now, those steps don't make a whole lot of sense right now, but we're going to walk through it now. So step 1 is to find the average value of this function. So I'm going to do 1 over 3 minus 0 times the integral from 0 to 3. Sorry, that's a 3 right there. Of our function, x squared minus 2x plus 3 dx. So I've got 1/3. We'll take this antiderivative. This is going to be 1/3 x cubed minus x squared plus 3x, being evaluated from 0 to 3. This is 1/3, and I'm going to do a little bit of plugging in and simplifying at the same time. When the 3 gets plugged in here, because remember I plug in the top minus the bottom, when I plug in the 3 here, I'll get 27 times 1/3, so 9 minus 9 plus 9 minus 1/3 times, and when I plug in 0 to all of these, I'm just going to get 0 for all of them. So in short, I'm finding that this is going to be 1/3 times 9, and so the answer I'm getting for step 1 for the average value of the function is 3. So this is my average value of f, right? So now I want to scroll back up and take a look at the mean value theorem for integrals. This thing says that f of c is supposed to be equal to the average value of the function. So how am I going to find c? I'm effectively going to do that by moving on to step 2. Step 2 in this process is, according to my list on the right, to set this average value of the function, to set 3 equal to the original function. And it's basically like I'm saying, well, let's set 3 equal to f of c. So what is f of c? Well, if f of x in the beginning of the problem was x squared minus 2x plus 3, then f of c should simply be c squared minus 2c plus 3, and that thing is supposed to be equal to 3. So just to recap that real quick, I took the average value of the function and I set it equal to f of c, where f of c basically means the original function with c plugged into it. So I have original function with c plugged into it equals the average value, and that, I mean, congratulations, that was step 2. Step 3, if you see up here at the top, is solve for c. Now you have a little equation, solve it. If I move the 3 over, I'll end up with c squared minus 2c equals 0. And then I can solve this by factoring. C times c minus 2 equals 0. So we can see that c has to be 0 or c has to be 2. And the question is, like, is it 1? Is it both? What is it? And if you refer back to the original statement of the mean value theorem, what we're looking for is, it says here that there's at least one value of c on the interval, and I believe it's an open interval from a to b, which means we technically don't include a and b. So if the question is strictly asking you to find the value of c that is guaranteed by the mean value theorem, you're looking for the one that meets that requirement. So in our case, the value would be 2. And yay, we solved the problem. We answered the thing. I do, however, want to look at a graph because I want this to make more sense than, yay, I got to the answer. I want us to see where this comes from. So I'm going to pause this for a second. I'm going to bring up a picture so we can look at this. The point that I'm about to make is going to be really important for the problem I'm going to do right after this. So make sure you've got your brain turned on for this. This is a graph of the function we were just talking about. This is a graph of the function f of x equals x squared minus 2x plus 3. Now, what did we find in this problem? In step 1, we found out that the average value of this function was 3. And so when I talk about average value, I'm talking about a y value. So if you think about where does a y value of 3 happen? Well, this is where a y value of 3 would happen. Or maybe I should use another color for that. A y value of 3 means here. Now, the question that's effectively being asked is, when is f of x equal to that thing? And in fact, what it really is, at what values of c is f of c equal to 3? Notice that the answers I got were 2 and 0. It just so happens that 2 and 0 are the places where the 3 line intersect our function. And that makes sense. And I hope it does. If not, rewind and look at this again. What this theorem is saying is it's saying that the c values are the x values where the average value is the value of the function. That's actually what we're looking for. So like I said, I'm hoping that you can take that graphical knowledge and apply it in the next problem we're about to look at. So let's see what we've got next. Okay, so we have the graph of g of x, and I want us to approximate all values of x on the interval from 1 to 6 for which the function is equal to its average value on the interval. And I apologize, this function is handwritten, but it's the best I could do. So the idea here is what do they want? Well, first they want us to approximate x values where the function is equal to the average value. And I hope you guys recognize that's basically the mean value theorem for integrals. I'm not saying find the value of c guaranteed, but it's the same setup. The first thing we need to do is we need to actually find that average value. And the way that we're going to do that is the same way we've been doing, for these whole videos. 1 over 6 minus 1 times the integral from 1 to 6 of my function. Right? So, great, I'm going to need to look at this function between 1 and 6. and determine what that area is. So right here I've got a triangle that's 2 by 2, so that area is going to be 2. Here I've got a triangle that's 2 by 1, so that's an area of 1. And here's a square that's 2 by 2, which means this thing here is an area of 4. So overall, that whole integral is 7, right? So if I want to find the average value, it's going to be 1/5 times 7, which is 7/5, which is 1.4. So the average value of this function is 1.4. Now the problem is asking me to approximate the x values where this function is equal to 1.4. Right? So effectively what that means is I need to look, where does this function that I've drawn, where does it have a height of 1.4? So what I'm doing is I'm just drawing a horizontal line at 1.4 to indicate where the height of 1.4 would be. It looks to me that it happens right about there. And then again, kind of over in this neighborhood. And again, I'm looking for an approximation here so we can come up with something close. If we follow this x value down, it looks like it happens at x equals 1.6. And then also this value here, and we could actually find out exactly what this is, but I'm just looking for an approximation. This looks like it's between 3.6 and 3.8. We could call it 3.7. It might be 3.6 repeating. We're looking for approximations, so those are good enough. This last example is really just to serve as an example that these problems can be done with a graph. Even if I don't give you f of x equals blah, 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 because we can find the area under a curve and use that to approximate an integral, we can also use that to talk about average value in places where it happens. That's the end of this lesson. I would definitely recommend you guys try a couple of the assignment problems before class tomorrow, but I will see you then.